Okay, this section's it's going to get a little bit difficult, okay? So bear with me, take really good notes. And I know it's going to get confusing. You're going to be confused. That's okay. We're going to work through it, okay? Just stick with me. All right, let's talk about quantum mechanics. With quantum mechanics, there's a couple of principles or rules that we need to follow. So first, there's the Heisenberg uncertainty principle, which states that you can know an electron's velocity, but not its location. Or you can know the location of the electron, but not its speed. Okay, so you can only know one of these two items at a time. It is impossible to know both at the same time. Okay, next we need to talk about Schrodinger. So you guys have probably heard about Schrodinger and his cat, right? Don't worry, this equation, you don't need to know it. You don't need to know how to use it. You don't need to add it to your equation sheet, okay? But Schrodinger used this equation and stated that there are a finite number of solutions to this equation, which correlate to the energy levels, those orbits where those electrons can exist. Okay? And what this equation does is it defines the probability of finding an electron in a specific location. Okay? Okay, so I've been using this word orbit. Let's define this a little bit better. So an orbital is the electron cloud. Okay, so remember the protons and the neutrons live in the nucleus, and then the electrons are constantly moving around the outside of the nucleus in the electron cloud. Okay, so an orbital is a region in space where there is a 90% probability of finding an electron. Okay, so we call that an orbital. Okay, next up we're going to learn about quantum numbers. Okay, quantum numbers, there are 4 of them. Okay, so every electron gets 4 quantum numbers, and these specify the address of each electron in the atom. Exactly where can you find it, okay? And this number is unique to each individual electron. So think about your address. So when you write an address on an envelope to mail it to someone, you're going to include the state. That way we know which state to send it to. Do we send it to South Carolina? Do we send it to California? Do we send it to New York? So we get that general region of where it's headed. Then you're also going to include a zip code. The zip code is more specific to the city that the person lives in that you're mailing it to. Then you're going to include a street address so we know where in the city this is going. Then you're going to include a house number. Okay, so it's very specific, and so that's kind of how you can think about these 4 quantum numbers of electrons. It's kind of like an address. Or for you sports people, when you get a ticket to go to a basketball game or a concert where they have like assigned seats, it's the same idea. On your ticket, it's going to tell you your general area. So are you on the upper level or the lower level? Then it's going to tell you your section. Are you in A section, B section, C section? Then it's going to tell you what row you're sitting on, row 12. Then it's going to tell you what seat in that row. Okay, so getting more and more specific. All right, so you've got your principal quantum number. This is represented by N. This tells you your energy level. So it gives you an idea of the amount of energy required to move this electron. It's also going to tell you the size of the orbital, okay? Because as your N gets bigger, so does the energy, so does the size of that orbital. Then you have your angular momentum quantum number. This is represented by L. Okay, this is your energy sublevel. So if you're in level 1, you can have a sublevel. If you're in energy level 2, this would be your energy sublevel. Okay, this is going to tell you the shape of the orbital. Okay, there are 4: S, P, D, and F. Okay, so S is a sphere. P is kind of shaped like a barbell. D is shaped sort of like a flower, and then we start getting really funky with F because it's really big. Okay, but this angular momentum quantum number is going to tell you the shape of the orbital that it's in, either S, P, D, or F. Next, we have the magnetic quantum number. This is M sub L. This is going to tell you the orientation of the orbital, okay? Because remember, an atom is in 3D space. So is this lined up along the x-axis? Is it lined up along the y-axis, the z-axis? So that's what that third number gives you. It specifies the exact orbital within the sublevel, and it's going to give you an orientation. Okay, so for example, the P, remember we said the P looks like a barbell. These are the different orientations that it can take, okay, the different directions it can be going in. Okay, and what happens is all of these orbitals in an electron, they sort of overlap one another to form that sphere around the nucleus. So this is an S and the P's all combined together. Okay. But still, this area is showing where we can find an electron. Our fourth and last quantum number is the spin quantum number, M sub S. There's only two options for this, positive 1/2 or negative 1/2. And what this does is it is a representation of what direction that electron is spinning in. Okay, so every orbital can hold 2 electrons, but they have to spin in opposite directions. Okay, so one's going to have an upward spin, that's the positive 1/2. One is going to have a downward spin, that's the negative 1/2. Okay, and all 4 numbers come together to create the specific information about an electron. We also need to think about the Pauli exclusion principle. Okay, this states that no 2 electrons in an atom can have the same 4 quantum numbers. If one is in one location, it excludes all other electrons from being in that location, which means that each electron has a unique address. Okay, so just a reminder, principal number tells you your energy level. There are 7, 1 through 7. Okay, corresponds to the periods on the periodic table, just like there are 7 periods on the periodic table. The angular momentum number gives you your sublevel, so that gives you the shape of the orbital, S, P, D, or F. The magnetic number is the specific orbital and orientation, and the spin number is this particular electron. Okay, so that's rounding it all up, those 4 numbers. This is sort of boiling it down to what those 4 numbers tell you. Okay, that means that every single electron we can give a particular information to. All right, so at this point, are you feeling a little overwhelmed? If so, that's okay. Stick with me, okay? The next lecture is going to show you how to use this information. We're going to work through some example problems so you can see how all of this is going to come together, okay? This particular lecture was about getting the vocabulary and getting that base bit of information. Now let's go see how we can use it, because this will make sense soon. So stick with me.